Hi everybody, welcome to another section in Math 1324, section 1.2, graphs and lines, Cartesian coordinate system. So Cartesian coordinate system, we have all the coordinate x-axis and the y-axis perpendicular to each other, and the horizontal axis is called the x-axis, the vertical axis is the y-axis. So horizontal is the x-axis, vertical is the y-axis. They intersect at the right angle, and that called the origin. Label that x, O. The two numbers line divide into plane. So here's a number line, 0 in the middle, positive on this side, negative on that side, and positive up and negative down. With that, we divide this into 4 quadrants. This is called quadrant 1, 1, 2, 1, 3, and quadrant 4. And any two number, for example, if the point here associated to the number, the x values on the x-axis and the y values on the y-axis, and we consider this point x, y. This is called the order pair. The first one is go with the horizontal or the x-axis. The second one is go with the vertical or the y-axis. Now let's see. Let's plot the point -3 and 4, and then 3 and -2. Right. First 3 and -3 and 4. So x is -3 and y is 4. So we have this -3 on the x-axis and 4 on the y-axis. That's what we have. Next, 3 and -2. So 3 on the x-axis and -2 on the y-axis. So the point here is 3 and -2. Right. So now we just graph linear equation in two variables. So we have linear equation, two variables. So we have x in this and y in it. And so we have some x, some y equal to some constant. And the key here is a, b, and c are constant, but a and b are not both equal to 0. If both of them equal to 0, we don't have any x or y. So that cannot be a linear equation. We have at least one of the variable not equal to 0. Right, anyway, x plus b, y equal to c. Right, let's say how do we graph them? Right. Of course, there will be a few more theorems. The graph of this equation is a line. So when we have this equation, when not both equal to 0, it is a line. So that's why we call that a linear, because that the graph is the straight line. Here's some properties. If a and b not equal to 0, we can rewrite this in this form, -8 over b, which is equal to m, and both of them equal to the slope. It's defined to be a slope, because that will come later. And then if a equal to 0, we have this, which is the horizontal line. And when b equal to 0, we have this, which is the vertical line. And we will see that. Right. The x-intercept is when y equal to 0. So we have some coordinate for x, but y have to be 0. So that is the x-intercept. Y-intercept is when x equal to 0, y can be something. So that's what we have. Now, let's graph this equation. And to graph this, of course, you can choose any value for x, any value for y, and then we find 2 points, connect the graph. Now, let's say if we want to graph a line, if we have 2 points like this, we can easily connect them and make a straight line, right? Now, if 2 points are very close, it's kind of difficult to draw a line because there are too many variables, so kind of more difficult. So likewise, if we want to graph, we need 2 points, preferably 2 points that are a bit further apart, so it's easier to draw a line. Right. the park where I say it is further apart, it's just for application. We want it is easier to draw a line when we have 2 points further apart. Right. Now, regardless, when we graph it, we just need 2 points. So x and y, we need 2 points. Right. To make things simple, let's say if we get x equal to 0, so let x equal to 0, put 0 in for x. So, and then we solve for y. There's no x here, so I divide by -4 on both sides. So y equal to -3. When we left y equal to 0, let's say -3, so 0 and -3. When y equal to 0, I'm going to put 0 in for y. So 3x equal to 12. Divide by 3 on both sides. We have x equal to 4. And we just plot x equal to 0, y equal to -3, x equal to 0, y equal to -3, and x equal to 4, y equal to 0. So we have these 2 points, and connect them, we have the line. Of course, you can choose x to be equal to 0, y equal to 0, or x equal to 1, y equal to whatever it is. So choose one x, 5y, and vice versa. Right. So here, of course, I can choose x to be 0 again. And then I can choose another value for x. However, I don't want to choose 0 and 1, being that if 2 points are too close together, it's kind of difficult to draw the line, right? So 2 further points apart is easy to draw. Preferably we choose 0 because it's much easier to solve for. At x equal to 0, we have 2 times 0 plus 5y equal to 10. Divide by 5 on both sides. Let y equal to 2. Now let y equal to 0. 2x. Let 5 times 0. And then we divide by 2 on both sides. We have y equal to 5. So when x equal to 0, we have y equal to 2. We can just say, we can solve for that. Just go over the x. We have 5y equal to 10, divided by 5, we have 2. Likewise, go over the y, to x equal to 10, divided by 2, we have 5. So x equal to 0, y equal to 5, x equal to 2, x equal to 0, y equal to 2, and x equal to 5, y equal to 0. You have this line. Right, so that. Yeah. So that. Now we graph x equal to -2, right? Actually, this is a little strange. We know x is going to be -2. We're not going to be able to choose anything else for x. So x have to be -2. But y though? We can choose anything. You can choose 0. I can choose any number. But if we choose the smaller the number too close to 0, difficult to draw a line when 2 points are too close. So make the point a bit further apart, about 5. So then we just plot the points and connect them. We have the line. When x equal to -2, y is equal to 0, x equal to -2, y equal to 5. So we have those 2 lines, 2 points, and connect them, we have a line. So this is x equal to a constant, it's a vertical line, so keep that note. So this is the vertical line. Now we have y equal to constant. So we make a table and we choose 2 points. Y have to be 1. X though could be anything. Again I choose 0 and maybe -4. I set a point a bit further apart. X equal to 0, y equal to -4. Sorry, x equal to 0, y equal to 1. X equal to -4, y equal to 1 as well. So again, when we have y equal to constant, that we have a horizontal line. And next we define the slope of a line. So the slope is the line with 2 distinct points. So it's defined to be like this. So the change in y over the change in x. Or the change in y, or we think how much we change vertically, or usually because from that the rise over run horizontally, rise up and down vertically. Right. So in that case, let's say we have here the point x1, y1, here x2, y2, and the slope of that line is given by this equation. The slope of this line is the stiffness of the line is given by that. Right. Now let's look at some scenarios here. We know the horizontal line when y equal to a constant. So the slope usually is m equal to 0, and the vertical line, there's no stiffness, so that's called the slope is undefined. When we have the line is rising, the line is rising, so as we go to the right, we're going up, so rise up, so it's positive, and going down is negative. So that different scenarios. Rising, the y going up, rise up, positive. When falling, going down, it's negative. The slope is negative. Equal to 0, that's flat, and undefined when vertical line. So we have some summary. So there are 3 different forms of the equation of the line. The standard form we've seen before. When we write like this, we call the slope is m, b is the y-intercept. So slope and intercept form is mx plus b, and the point slope form is given by this. 3 different forms of the line. For horizontal line, we have y equal to constant, and vertical line we have x equal to constant. Right. Now let's look at some example here. Write the equation for the line that have the slope. So we have the slope m equal to 1/2, and pass it through the point -4 and 3. Run on 3 form. So 3 form we will work between this form. So first, we have the point and we have the slope. So that's the point slope form. Point and slope form. Y minus y1 equal to m x minus x1. Y is y, y1. When we have this point, x1 is -4 and y1 is 3. So we have y minus y1 equal to slope x minus x1. So y minus 3 equal to 1/2 x plus 4. So that is the point slope form. Now if we want to the slope and intercept form, we're going to solve for y. I'll multiply this out. And 1/2 times 4 is 2. And we solve for y, so we get y by itself. Y equal to 1/2 x plus 5. Right, another standard form. So we have this. So the standard form, we're going to move x and y on one side. So we start with this. Let's move x and y on one side. So why don't we do this? We have negative 1 over 2x plus y equal to 5. Right, that's good. But in the standard form, we don't want any fraction here. So let's multiply negative 2 on both sides, so that kill the fraction here. If we don't want to, I preferably multiply by negative 2. So why do we multiply by negative 2? Multiply by 2, we cancel fraction. Multiply by negative, give us the first coefficient to positive. Negative 1/2 to negative 2, so that is x. Negative 2y equal to negative 10. And that is the standard form. Right, all three forms. Questions we need the slope, point slope form, slope intercept form, and standard form. Right, next. We'll do the same thing, but this time we write all three forms. The line which go to this point and this point. So this one we have 2 points instead of a slope and a point. So let's say the x1 is 2, y1 is negative 3, x is 4, y is 3. So we don't have the slope. So if we want to find the slope, y is overrun. Change in y over the change in x. Right. We can call this point x1, y1, x2, y2, or we can say x2, y2, x1, y1. So y2 is 3 minus y1, x2 minus x1. So that gives us 6. 3 minus that 3 plus 3 is 6. Negative, negative. Subtract negative, that turn to positive. That's 6. 4 minus 2 is 2. 6 divided by 2 is 3. So you have the slope is equal to 3. Right, and then the ring symbol repeat. We have the slope now. Just say the point slope form. So y minus the slope, y minus y1. Again, we can choose one of either point here. So I just choose this point, y minus y1 equals slope x minus x1. So y plus 3 equal to 3, x minus 2. We don't multiply that because we want the slope to be that number. one the parentheses here. That is the point slope form. Slope intercept. We go to gonna solve. We're just gonna solve for y. And we multiply this out. That will be 3x minus 6 and minus 3 on both sides. Now go to 3x minus 9. Right, so that is the slope intercept form. And then the standard form. Just move everything on one side. So from here minus y. So that gives us 0 equal to 3x minus y. Oh, minus 9. Of course, if we want the 9, we move to the other side. So the standard form, we have 3x minus y equal to 9. So, of course, on x and y on one side, preferably there's no fraction. Preferably the x is coefficient of x positive. So that's what we have. Right. Now write equation. This with 3 forms. Right. So let's write x1 is 2, y1 is 5, x2 is 2, y2 is negative 1. So we start with slope. y2 negative 1, y1 5, x2 is 2, x1 is 2, so we have negative 6 over 0, which is undefined. So the slope is undefined. Yeah. So if the slope is undefined, we cannot write the slope intercept form. So let's write slope. I mean the point slope form is non-existent, or the slope and intercept form both of this does not exist because the slope does not exist. So the standard form have some x equal to, let's say, ax plus by equal to c. But this instant we can just go straight and say we said doesn't matter what y is, x is equal to 2. So we only have standard form in this case. Right. Let's look at some application here. The management of a company that manufactures skateboard have fixed costs of $300 per day, and the total cost of that output 100 skateboard per day. Assume C is the linear related. Find the slope, and then find the cost equation in slope intercept form, and then find the cost of producing 150 skateboard per day. So in this case, output X. So in this case, X is the number of skateboard, sorry. And let's say Y, or C is the cost. Let's say Y is the cost in dollars. So let's say X and Y. Now the fixed cost of $300. That means if we produce no skateboard, we still have to pay $300. Now the total cost. The total cost of the fixed cost meaning produce nothing, we still have to pay that. The total cost of 4,300 when we produce 100 skateboard. So we have to set the points, we can find the slope. Slope change in Y or change in X. Y2 minus Y1 over X2 minus X1. So 4,000 over 100. That gives us 40. So the slope of 40. So what that 40 means? 40 means is what the number 40 in what the slope, meaning that each skateboard, the variable cost for each skateboard is 40. Right, write the cost slope intercept form. So that equation. So if we know m of 40, that's what we have. Now we just pick a set of point when x equal to 0, y equal to 300. So you can solve for that. 40 times 0 is 0, 300 is equal to b. So the equation is in this form: y equal to 40x plus 300. And in application, you can see that the 300, the intercept, is the fixed cost, and the 40 is the variable cost, the cost to produce each skateboard. So the slope is the variable cost, and the fixed cost is the intercept. Now find the cost of the output of 150. Now that's easy. We have y equal to mx plus b. In this particular 40x plus 300. Now if we want to produce 150 skateboard, just that. That will be 6,300, I think. $6,300. The cost to reduce 150 skateboard. Right. Now we have another application here. So supply and demand. Supply and demand. The supply is it's just the equation that quantity and the price. So I just want to draw two lines here. One line going down and one line going up. So let's say we have the horizontal axis is the quantity and the vertical axis is the price. So which one is the demand, which one is the equilibrium, which one is demand, which one is supply? So thinking about this, if you are a consumer or you demand some type of merchandise, the cheaper the price, the lower the price, the more willing you to buy. So if things go on sale, you want to buy more, you more willing to buy, or the demand for something will be increased. So the price going down, demand going up. right? So line going down is called the demand line. And the supply, if you are producing something and if the cost, I mean, if the quantity, if the price of that item increase, you want to reduce more because you can sell more for more money. So the higher the price, the more willing for you to sell, the more willing to supply. So the supply is the line that's going up like this, and whenever it intersects, it's called the point of equilibrium. So it's kind of the compromise of the two. Right. So let's look at some example here. At the price of $9 per box of oranges, the supply is that and the demand is that. At the price of $8, the supply is this and the demand is that. Find the equilibrium point. So first, find the price supply equation. So in that case, we said the quantity is X and the price is Y. Right. So let's make a table. Right, of course you can say price and quantities flip-flop easily. Right. Or of course you can draw this quantity, the price horizontally, or the quantity of that as well. You can say the price and then quantity. Either way, we still have the demand. Sorry. Sorry, I have to change the line a little bit. So we still have the demand that going down, and as the price increase, the quantity decrease, and the supply going up. So when the price increase, the quantity rolling to supply increase. So like I said, you can choose either draw the graph like this. If it's linear equation, it doesn't really matter. Right. So when we say the price and supply, we want to write the X and supply, and then the price demand, the X and the quantity demand. So in that case, like I said, either one works for the linear equation. But when we say the price and supply, we mean X is the price and quantity supply is Y. Here we have price and demand. So X is the price. Sorry, I need to change the line. So it's easy to see. Mess up something. Right, I think that's much better now. X is the price, quantity demanded is Y. So price demand is X and Y, so the price is X in this case. Of course, you can choose either one of this when it's linear. Right, so let's say the price X and here the supply Y. So if we look at the supply, the supply, okay, $32, 3,200 at $9. At $8, the supply is 2,700. Of course, the smaller price, the less willing you want to sell, less willing to supply. Right, so we have 2 points here. So find the slope. X2 minus X1. Y2 minus Y1 over X2 minus X1. That gives us negative 5,000. That gives us 5,000. So the slope is 5,000. And now the equation, we can say y equal to mx plus b m. You can choose either of m is 5,000. Now we use, let's say this set upon x. So 2700 equal 5,000x plus b. X is in 8. So that gives us 2700 equal to 40,000. Subtract that, if b is equal to negative 1700. Subtract 40,000 on both sides. So b is this, and y equal to mx plus b, so y equal to 5,000 times x minus 1700. So that is the price supply. Now we do the price and demand. The demand will be 20,000 bucks when it's $9. But when $8, it will be a lot more willing to buy. Right. So we still do the same thing. Slope. Y2 minus Y1 over X2 minus X1. So that gives us 10,000 over negative 1. So M is equal to negative 10,000. Next, y equal to mx plus b. Negative 10,000 plus b, and then equal to y. Let's choose this set of points. I said you can choose either points. Up to 20,000. Forgot the x. And x equal to 9 plus b. So 20,000 multiplied, that is negative 90,000 plus b. Plus 90,000 on both sides. We have 11, 1 and 10 equal to b. So y equal to mx plus b, y equal to m x. M is negative 10,000 plus b that's what we have. Right. So price supply, price demand. price is x, y is quantity. Right, now for the equilibrium, so we just let these two equations equal each other and we solve for x. So we have equilibrium, meaning these two equations are equal each other. So just move on the x on one side. And you have 15,000 x equal to 127. Right, and then solve for x divided by 15,000 on both sides. So x, the price is about 8.466, so $8.47. Let's round that to the nearest pennies, and then we can substitute that in for x. So this is the price, equilibrium price. And if we want the quantity, we're going to substitute that number, this number, into either one equation. So I'm going to say this, and I say 5,000. I'm going to use this. Price and supply, 5,000 times that number, the price, subtract 17,000, and we have $25,300. Let's round up. Right, so this is the quantity. So equilibrium, the compromise price and quantities. The price is $8.47 and the quantity is 25,334. We just round up, or if you want to, round to the nearest one. Right, so that's what we have, and with that we finish section 1.2. See you in another video in Math 1324. Thank you for watching.